All right. Hi, everyone. Hope you can hear me. So my name is Tal. Um, we're going to talk about securing Lambda functions. Why am I doing this talk? So I've started with serverless about 4 years ago. I joined a startup called Pertigo. We did serverless security protection and got acquired by Checkpoint. Then I founded Cloud Essence, an application security testing for serverless that was acquired in 2020 by Contrast. I'm now heading Contrast Cloud Native Research, and you can find me on social media on the right, on the left side of the screen if you want. All right, so let's start. Let's talk about serverless in general, what it means. So when we talk about serverless, we actually mean a lot of things, not just some dev pattern or an environment or a technology. It means a different architecture for once is not anymore a monolith flow, big flow, but rather it's a composed application composed by many different resources which are not connected by default, and we just need to make the configuration to make them connect in some way and create the logic of the application. And this by itself has a lot of security challenges, and we'll get into that in a few minutes. The cycles are different, no more waterfalls. Of course, everyone talks about DevOps, and when you want to also add security to the equation, maybe you create DevSecOps, which is basically short cycles that also include security in them, of course, letting the developers and the operation run maybe together or as one to create a cloud native application. The processes, as Kyle says before, mostly automated. When you want to build in the cloud, you pretty much need to automate everything. Otherwise, it's going to be quite hard for you to keep track with everything. And that also means that the decision goes from a top-down decision where the managers or the managers are the ones that takes the decision when to move to production, when to deploy to production, when to do maintenance for the server. Developers now take much more responsibility and ship into production on a daily basis. A serverless architecture could be looking something like this. This is actually a very small type of account with just maybe a couple of dozen of resources and mostly APIs and Lambda functions. But you can see that there's some complexity over there, because there are many different resources or services which are not really related to each other. There is no one view to let you see what's going on in your system. If you're using here, in this case, AWS, you need to know how to collect information from many different services in order to try to understand what you have in your system. And when we look at environments of customers, some of them has hundreds and thousands of resources, and those graphs become really difficult to understand. But the graph, of course, is not the problem. The problem is that the organization, whether it's the security team or the engineering management, it's really hard for them to understand what's going on in the system. And of course, that by itself makes it hard to understand or threat model or to understand the potential risks. Okay, so let's deep dive into a Lambda function. What does it mean? Lambda function is the compute resource by AWS, lets you really run code without having to do or to deal with anything else other than running, creating or developing your code. You don't have to have a predefined budget. You don't pay for anything idle. You just pay for consumption, and consumption here we're talking about millions mostly. So basically, unless you're in a real active app, you can have a full-blown application with almost no payment at all. Of course, you don't have to deal with servers. Lambdas don't run. You don't need to manage the server that runs the system. Basically, from the development part is serverless. This is why it's called that way. Of course, there are servers that are maintained by the cloud provider, but this is all transparent for the user. Anyway, some event happens in the background, whether it's S3 buckets, APIs, tables, IoT rules, or something changed in the cloud you configured or you define that triggers the Lambda function. And then basically what happens is that AWS or the cloud provider spins up your environment with the code inside, executes the code. The code usually then interacts with other services or resources in the cloud. Once it's done, basically the Lambda environment is done. The problem is that even that it's a small part, it really is your code, and that could also means your mistakes, whether it's in the code itself or in the configuration connected to it. All right, some security aspects that we need to know about Lambda functions. So it's a read-only environment. If you want to write something, you have the /temp, so everything goes there. It's not wired to the internet, so of course the Lambda has access to the internet, to whatever you need, to whatever service you need, but you cannot SSH to it. So the runtime itself is not connected. You cannot have access to it. It's a built-in environment, and it's transparent for you. The data is temporary, meaning that when the execution ends, the data will end with it. That's stars next to it means that in AWS you have two types of execution. It's called warm start and cold start. Cold start is a new execution or a new environment spinned up for this specific code, means that there was nothing prior to that. And in that case, there is nothing there. The warm start is to basically, for performance reasons and prevent latency, of course, the environments are recycled if the code is the same. So in case you hit a warm start, so let's say you have an API calling a Lambda and you're calling it multiple times, there is a very good chance that you land on a warm environment, meaning that the data that was there before is still there. And that's also a security issue that we want to tackle. The code resides in the environment because this is how the environment runs your Lambda function. And also the keys, which means that the permissions we talked before, Kylo talked about IAM. So the IAM policies given to the AWS, to the Lambda function, are translated into some keys, to secret, AWS secret key and key ID. And those are the environment keys. And they also reside in the environments as environment variables. Of course, all of those has some security considerations. We did recently a survey with hundreds of security experts in serverless, developers or organizations that deal with developing serverless. And we asked them what issue they experience, what security issues they have. So you can see that most of the issues here basically have kind of a relatively similar amount of response, but misconfigurations and insider data leaks are the most. Misconfiguration in AWS Lambda is something that we will discuss soon. Okay, so what could go wrong? This is a very small type of some architecture, or basically it's just some 3 resources or 4 resources. As a user using client, whether it's Postman or a mobile app or a web browser, it doesn't really matter, makes an API request, that triggers a Lambda function. The Lambda function gets the IAM role related to it and then writes or reads from the database. What could go wrong here? So you say, okay, there is an API here. So there's a REST API. We should secure the REST API. Of course, this is kind of trivial if it's a web application. So you'd say, okay, API gateway is something, or the API connected to the Lambda is something that I want to protect. There are a few issues here as well, because before serverless, really the connection between the gateway to our code, to our server, was on our responsibility. So we could also put security measures on the network. In this case, could be firewalls or IPS or IDS or DLP or whatever we want. In this case, we don't really own the connection between them. So once a user creates a request, it gets into the Lambda and the code needs to protect itself. Okay, but this is really kind of a standard type of configuration, an API calling the Lambda function. What about this? There is a user talking to an Echo Dot Alexa device, right? Behind there is an Alexa skill and a Lambda function, again, writing or reading into the database. So this is something that is a little bit more, let's say, or less something that we interacted with before, and might be even something that is hard for us to understand what to protect. So in this case, we have the Echo Dot that we need to protect. The Echo Dot connection, of course, to the Lambda that we need to protect. Just a second. I really apologize. Once talking about Alexa, it was turned on in my place. Anyway, so when I showed before that we can interact and actually perform some security problems or really hack into our serverless application using voice command, using Alexa. I showed this at various of conferences, and most of the times developers came to me and said, oh, we really didn't know that there is something here that we need to secure, because the notion that we need to secure a voice command is not really something that we're familiar with. And that just to show that for serverless, we have to have some kind of a different mindset when we try to secure our Lambda functions. It basically means zero trust. It means that the code needs to protect itself, and there is no way for us, in many cases, to understand what is coming or what will be coming to the Lambda before we don't have that control, right? We don't have the control between the data transfer between the API to the Lambda in many cases, or the database to the Lambda, or in this case, the voice command to the Lambda. So we need the Lambda to be able to protect itself. One of the issues, so as we talked about, is loss of perimeter. We don't have the perimeter which we can protect anymore. We need to understand that that data or payloads could come to arrive into our code, into the Lambda functions from various of services or locations that we weren't expecting before. All right, so let's talk just a little bit about IAM. So functions has their IAM, their policies, their permission or access control inside the cloud, and that is based on their IAM policy. Each function must have its own IAM policy to allow it to perform actions inside the cloud. Here we have a very 20 lines of code function which has just one API, which is put item, which is writing date one line, one entry into the database. The problem here is that the policy given to the function is really permissive and very generic. It's DynamoDB star, and the resource is table/star, which basically means that in this case, the function has the ability to perform any activity on any table in the account. So it's in the account level. It doesn't really have to be the application level. And that's very problematic because if someone gains access, whether it's through the API or from the code or somewhere else through another service or a resource, they can really do a lot of damage to the account. And the idea is that the function should follow something called the least privilege principle, which really gives them just what they need. In this case, it would be put item into a specific database or a specific tables. In that case, the function permission or the possibility for the function to perform damage is really limited to just writing one entry at a time to a specific table. Of course, it could still be a problem, but it's much less. It has much less impact. Yes, when you do it for a single function, it could be easy, right? We saw 20 lines of code, so just a small change. But we have, if we have thousands and we have customers claiming they have 3 million functions, it's really hard to understand how to do it at scale. And there are a lot of issues when we talk about serverless in general. There are many services, not always all the developers knows about all the services they need to interact with. Yeah, I might know how S3 works, but if it's connected to an RDS server or a SageMaker or Alexa, I might not know how to make sure everything is secure. The developments are much more frequent and pushing more to production, creating value on daily basis, multiple times a day into production. How does the security team can really follow that? It's really hard to understand what is connected to what. We saw the graph at the beginning. For many of our customers, we talked to the security teams, they have no idea, really no idea what's going on. Yeah, they know they have about 500, let's say, Lambda functions in the account. Where they log into the AWS console, they can see 500 functions. But it's really hard for them to understand what is talking to what, because you don't have that single view on your cloud provider. It's really also hard to understand what's important in many cases, because if you have 500 functions, how do you know what to prioritize? And in many cases, they don't really even know if the security is the same, or if they can apply the same security techniques and mechanisms that they used before in 20 years of experience, in their previous 20 years of experience, should they apply the same techniques? And also, as we talked about, security for Lambda also contains infrastructure, because serverless is basically a mix of infrastructure and code. But infrastructure is not only always handled by the developers, right? There is DevOps in the equation. So we have three teams: development, DevOps, and security. In some organization, it's not so clear who needs to take care of what. Sometimes it's very progressive, the developer does everything. Sometimes it's really separated, the security team controls all the security controls. So this needs to be defined inside the organization. All right, so there are many serverless risks. Some of them are really equal to what we've known before. So event injection is basically what we know as the injection attacks. They are a little bit different because they can come from unexpected sources like voice commands or files or emails or queues or things that we weren't dealing with before. Broken authentication mainly talks about the fact that functions, or let's call them the Lambda function in this case, are stateless, and they're ephemeral and stateless. That means that it's not it's not so easy to maintain trust or security or authentication in some cases. You have to make sure your code can protect itself also from unauthenticated behavior. Data exposure exists in the cloud and outside, but when we talk about serverless and Lambda functions, we talk about the keys that reside inside the environment. If you can steal those keys, you can basically impersonate to the function in the cloud from your own computer. Just need the keys. You can write AWS commands with the keys from your computer and interact with whatever access the function is given to. And there are many other things like dependencies, which we know before, the system logging and monitoring. In this case, you'd have to grab them to know how to extract them from the cloud provider. We have the overprivileged functions. We talked about the IAM. Open resources are APIs or S3s or SNS or SES that are misconfigured and allow access to external or anonymous requests, anonymous users, and then they lead into the code, which we need. Then we need to deal with unauthenticated data or basically anonymous data. Denial of service, again, and denial of wallet. So the consumption of functions on one hand against the limited resources of functions on the other. Insecure share space is the data that is, in this case, the /temp inside the AWS Lambda that could be shared between multiple requests coming from different users. And we have to make sure that they don't have access to one another's data. All right, so can we apply security at the traditional AppSec into serverless? Right, so let's go over a quick trying to understand current AppSec tools, whether they can apply to security, to serverless security, and then we will summarize. So I took this from AWS website. It's the simple iRobot architecture, serverless architecture with just 3 lambdas. Just as a case study, it's really simple. Right, so first we say, okay, we can do SCA or dependency scanning, which is great. But it just covers the dependencies. It doesn't really cover our code. We don't know if our code or infrastructure or configuration is secure. But we can start with that, definitely. Then we can go to infrastructure as code. So we talked about Terraform, and there are, of course, others like serverless infrastructure or Pulumi. And yes, we can scan them for security, which is great. There are some great tools out there, and I recommend you to use them. But they still gives you 0 coverage for your code. Yes, you can find some misconfigurations. Your S3s are open, or your databases are not encrypted correctly, but you still don't have any coverage for your code. Right, so we can run IAST, right? IAST on modern AppSec. You can really do DevSecOps with IAST, and they're reliable and accurate, but they need servers to instrument so they can really follow the call within the stack. In this case, there are no servers, so basically it's really not really intuitive to run an IAST tool inside the Lambda. So what about that? Dynamic scanning, like you put a scanner into to your website and it tries to scan and find vulnerabilities. Problem is, it really requires endpoints, so REST APIs. So it will just give you a small coverage of your application. And really, they rely on synchronous interactions, so requests response. And in many cases in serverless, the request just triggers another flow inside your system. So in this case, the Lambda will write something to the SQS and another Lambda will pick it up and the response will be okay. So there is really nothing to scan here using DAST. So SAST, the T dropped, it's a SAST, static application security testing. Really, the problem with current static application security testings are that they're looking into traditional flows, the start, from the API, go through all your system, and then where they end in the database on the response. But they cannot really scan your infrastructure, which means they see three, in this case, there are just three, but if you have 500, it's 500, three different applications with a start and an end. They can't really connect the flow. That gives a lot of false positives and a lot of noise, and really not what you need when you want to build your serverless application. So we built something different, and there is, because we're in the cloud, and we is just an example, you can also do it yourself. Because we're in the cloud, we can see everything if we collect the right data. So we can see when someone, in this case, Mario creates a new API, you can pick it up from your CloudTrail, right? A new API was created, a new function was created, the function code was changed, and you can pick it up with automation and start scanning those flows and try to understand really what's going on, what was changed, what is the policy, do we need to secure the policy, or do we need to scan the code, and then try to understand where the problems are and what's your impact. Because when you find a vulnerable Lambda, you know what the potential impact, because it has a policy inside your cloud, so you know what's your problems, potential problems. Of course, we should automate this process. You cannot be a per incident investigation, because it will not work. So with automated testing, you can find things like least privilege permissions in your code or vulnerabilities in your applications with an automated in an automated way. If you want to understand more about serverless security, so I'm really wrapping it up now, there are some interesting open source projects, so you should check out OS Serverless Top 10, which really is an open, built by the community project that is working on finding the security considerations for Lambda functions and serverless in general. There is an open core still running to gather data. And even nicer, I'd say, a DVSA, a damn vulnerable serverless application, which you can deploy on AWS with just 3 clicks, have an application, a full application working with a couple of dozens of resources and built-in vulnerabilities inside them, which you can explore both for securing and the offensive side of them to understand better the security. It's an OS project, but it's also on GitHub with some lessons and some documentation, and you can find information about it from the community. Just one note, don't deploy it on an environment which has sensitive information, because this information might be accessed, or at least could be accessed for external users. That's it.